Hi everyone. This is the first example. The question is you have to find the momentum of photon of wavelength 5000 angstrom. So they have given you the momentum value. Sorry, they have given the value of wavelength and you are supposed to calculate momentum. Now we have a direct formula of momentum. That momentum is h by lambda. Okay. So we are going to substitute the values 6.6 into 10 raised to power minus 34. That is the Planck constant value divided by wavelength, that is 5000 angstrom, means 10 raised to power minus 10. So when you solve this one, you will get the answer as 1.3 into 10 raised to power minus 27 kg meter per second. So that is option A. Okay. So let's move to the second one. In this one, example number 2, you are supposed to calculate the number of photoelectrons of wavelength 600 nanometer emitted by 330 watt bulb per second. So they have given you power. So power is energy radiated per unit time. Okay. So we know that power is energy radiated divided by time. So here in 1 second, we know that 30 watt of energy is being radiated. Okay. Wavelength is given as 600 nanometer. So can we calculate the energy of one photon? One photon, the formula of energy is Sc by lambda. Okay. So substitute the values here. Planck's constant value 6.634 into 10 raised to power minus 34 into C value is 3 into 10 raised to power 8 divided by wavelength, that is in nanometers. So 600 into 10 raised to power minus 9. Okay. So this is energy of one photon and this is a total energy. So number of photons is total energy divided by energy of one photon. So just substitute the values, like you have to divide total energy 30 watt divide with this whole thing. So after that, on solving, you will get an answer as approximately 10 raised to power 20. So that will be our option B. Okay, thank you.